welcome to this 10th devlog. We're gonna go through a couple of things that we have worked on in the past few weeks. Again, sorry that we don't post very often. As you guys know, this is a side project, part-time project for now, where me and Justin are working on this, so we're only two people. And we both have full-time jobs as developers. And so this is one of the reasons why we don't really post that often. One thing that we worked on though recently is the temperature canvas. So this little thing here, what we wanted is a way to display objects temperature dynamically. And so I created this little display that's going to follow the camera. As you can see right now, it's off, but when you play, it's actually following the camera. And yeah, so the purpose of this is to show what the temperature of something is on the front end. So as you guys might know, different objects can have or are called containers in our code, and they can have liquids or solids in there. And liquids, for now at least, have a temperature. And so for instance, this kettle, we can heat it up. As you can see, if you watch the previous vlogs, you can start heating or you can stop the heating process. But there was no way to know what temperature it was for the player. And so I created this, and I'm going to show you how that works. So on the core is very simple. It's simply a canvas prefab with a couple of images. So there are two images, one that is the background, which is just this little thermometer icon I made, and the fill image, which I can dynamically fill in code later. So we can display in a cute way the temperature of something. So when it's going to be really hot, it's going to be like that, and then the colder it's going to lower. That's the visual of it, the front end. On the back end, I created a class called temperature UI controller, as you can see, and there are two serialized properties there. The very first one is a gradient. So if I open the code here, you're going to see that there's the gradient that is just some sort of a way in Unity to display different colors. So I can have different colors, blue for cooler temperature, yellow, orange, and then red for the hotter it gets. And then I have the fill image that I drag and drop there, which is the inside that I showed you that I'm going to fill up and down. And in this class, I created 4 different methods. One that is to show the temperature. And so whenever I call this, I'm going to need to pass a temperature state. And this temperature state is simply either it's hot, warm, lukewarm, cold, or nothing. For now, and we might change that in the future, but for now that's what it is. And the current temperature, the reason why I want to have this temperature state and not just a float as a number is I want to simplify it for the player. We don't want to display in the game like 52.3 Fahrenheit or something like that. It's too specific. We want to streamline it and make it very simple for the user. And so in the back end, yes, we're going to use floats. So you can see that I actually pass a more precise temperature there. But then I break it down and I show it just as a text simplified version for the user. And then I have this coroutine that just shows, I'm using DoTween to show the canvas. So it just shows the UI. And then If it hasn't been called for more than a second, I hide it back, and I'll show you what that does later. Hide it is just the opposite of showing. So I play with a canvas group, and I'm just putting its alpha to 0. And here I have this little method that converts a temperature state to a color. So you might be wondering, wait, that's not a color right here. That's a float, that's a value. And that's because I used a gradient. And the way that works is a gradient in Unity can be used from, you can see this as being 0 to 1. And then if you can evaluate that gradient, for instance, and say, the value is currently 0.5, and then it's going to return whatever it's here. And here is yellow in this case. So if I say it has a value of 0.5, it's going to tell me it's yellow. And if I say it has a value of 1, it's going to say it's red. And if I say it has a value of 0, obviously you understand it's going to say it's blue. So now in action, what happens, as you can see, if I am to play, and I get to this kettle, there's no temperature shown right now. That's because I only call show, the method show, if I start heating or if I stop heating. So I only call it when the temperature actually changes. So if I start heating it up now, so I press R, you can see that the temperature is now displayed. And it always looks at the camera, and currently it's blue and it just changed to yellow then, and that just shows to the player that it's currently heating. It's not fully ideal yet. We might iterate a little bit more later on because it's not really precise, but it works for now. It tells me that it's heating up, and then since the temperature is still moving, it's gonna display until it stops, right? So every time the temperature changes, the thermometer will display. And you can see it's slowly going up in temperature. It will probably change to yellow, to orange eventually. If we can accelerate the process there. There you go. And now if I stop the heating after a second, the thermometer will fade. Yep. Another thing we wanted to do this in our last sprint for this vlog is we want to make this trash can kind of functional and not just a prop in the environment. So be able to trash stuff and stuff like that. So we created this class called trash bin. Again, very simple. I'm gonna run through it. It inherits from our class, which is interactable. Any interactable in the game needs to inherit from that class. This holds property that you can interact with this object. Potentially you can have ingredients in it or liquid solids, as I mentioned before. So this is all handled by our interactable class. Since I want to be able to interact with the trash bin, it needs to derive from that. Then I added a float value for later use, which is, well, actually for now too, but I mean, it doesn't really solve any purpose right now. Serve any purpose, sorry. So it's gonna fill up the more you trash stuff, and when it's full, you're gonna need to empty it. That's all this is gonna do. This is for the animation, so find the hinge of the lid to be able to rotate it when you interact with it. Basic stuff in start. Then you have 3 methods. Either you can trash something, empty the trash bin, and there's the trash animation playing. When you trash, I check here if the trash fill percentage is not full, so if the trash bin is not already full. And if it is, I call something on our feedback manager that I'm gonna run through in a bit, and I say that the bin is full and it needs to be emptied. This is something we worked on as well. I'm gonna show it to you in a bit. And then it returns, meaning it blocks the rest of the code. And this is stuff to know which object you currently have in your hands and to drop it and disable it and destroy it, because you're trashing this object that you currently have in your hands. And then this is temporary. I'm actually gonna go and add a to-do here because we just had 5% usage on the trash bin, but this is something we're gonna need to look into later on. And then I play the trash animation. The trash animation here is just, again, doing stuff. So I take the hinge of the lid, I rotate it by a certain value, and I play that animation with a ease type of out bounce. So it does a little bouncing juice stuff there. And then when you empty it, it puts the percentage back to 0, and I call feedback on the front end saying the bin has been emptied, just so the player knows that this happened. In action, what that means and how that plays out, I'm gonna show you. It's very, very simple, straightforward. So you can take something in your hands. So for instance, a small cup here, and then you can go to the bin and it's gonna say trash it if you press E. And if I do, you can see that it plays that little animation I was talking about, and that's it. Yeah, and if I am to empty it now, as you can see, it says empty. If I don't have anything in my hands, it says empty, so I can hold it. It takes 5 seconds. You can see it filling up, and then as I said, there's this message that is displayed, so I know that, you know, something happened, because visually right now nothing really happens, but when it's gonna be full, potentially there, like, it's gonna look full or something, I don't know. As I mentioned earlier, this feedback manager class that we have is a singleton class that you can call from anywhere, just like I do here from the bin. So I call spawn message, and then you just pass in the message that you want to spawn. And I do this in most of the games that we develop. I just find it really useful for early stages and even later stages to display any UX feedback to the player. And so it's very simple. It's just a UI, and as soon as it receives a message in here, it's gonna start that coroutine that shows the feedback in question. And so I put a bullet true to make sure that I cannot spam like a bunch of messages at once. So if there's already something displayed, it's gonna just wait. I showed a message with an animation sliding in the screen, and when it's done, I put that there's no more message, and that's it. That's very, very simple stuff. That's it for this week, guys. Thank you for watching as usual. You can follow us on Discord, on Twitter, and we're on Patreon as well. So yeah, thank you for watching, and see you guys in the next vlog.